Picture this. You finally built a RAG system, and you did everything right. Clean chunks, good embeddings, a re-ranker on top, the full textbook pipeline. Then someone asks it one simple question. Which of my projects depend on this one tool? And it answers. Instantly, confidently, and completely wrong. Here is the uncomfortable truth nobody puts in the tutorials. The RAG everyone is teaching you is version 1, and version 1 is already obsolete. In this video, I will show you what replaced it. Retrieval that thinks and checks its own work. Retrieval that follows relationships instead of similarity. And one more thing. The most powerful AI coding tool on the planet ships with no vector database at all. 0 embeddings. And it can still find anything on your machine. By the end, you will know how all of it works. And you will see my own second brain wired up with these exact techniques. Let's go. First, 60 seconds of context, so everyone is on the same page. RAG stands for Retrieval Augmented Generation. Instead of retraining a model on your data, you let it look things up. Your documents get split into chunks. Each chunk becomes an embedding, a point in a space of meaning. Similar meaning, nearby points. When a question arrives, it becomes a point too. The system grabs the nearest neighbors, pastes them into the prompt, and the model answers from them. I made a full beginner video on this. It is linked below. But look at the shape of this thing. One query, one search, top few results, done. No second chances, no follow-up, no judgment. That shape is the ceiling. And that ceiling is exactly where modern retrieval breaks through. Naive RAG fails in 3 specific ways. Hold on to these 3. They are the map for this entire video. Failure 1. It is one shot. The system searches once and commits. If the right chunk did not surface, nobody notices. The model just answers from whatever came back. Garbage in, confident garbage out. Failure 2. Similarity is not relationship. Embeddings find text that looks like your question, but the facts you need are often connected to your question while looking nothing like it. Failure 3. There is no judgment, no step where anything asks, did we actually find the answer? Retrieval is a reflex, not a decision. Now here is the good news. Each failure has a fix, and the fixes have names. An agent in a loop fixes one shot and fixes judgment. That is Agentic RAG. A knowledge graph fixes similarity. That is graph RAG. 2 upgrades. 3 failures solved. Let me show you both. Let me make failure too concrete, because it is the one that stings in production. Ask this. Who reviewed the pull request that introduced the bug that caused the outage? A human hears a chain. Outage, back to bug, back to pull request, back to reviewer. 3 hops. Vector search hears vibes. It returns the 3 chunks that smell most like outage. An incident report. A post-mortem template. Someone's outage. Retrospective from last year. All similar. None connected. The answer needs a join across documents, and nearest neighbor search cannot join anything. Here is the line to remember. Similarity is not causality. Looking alike is not the same as belonging together. Every knowledge base has these chain questions. Who owns what? What depends on what? What changed before what? And naive RAG gets them wrong with total confidence. Fix number 1. Stop treating retrieval as a pipeline. Start treating it as a loop. In Agentic RAG, the retriever is an agent. It gets tours and it gets turns. Watch the difference. The pipeline goes embed, fetch, answer. Straight line, fire and forget. The agent goes think first. What am I actually looking for? Then search. Then read what came back. Then the step that changes everything. It judges. Did this answer the question? If yes, stop and answer with receipts. If no, rewrite the query, pick a different tool and search again. Search, read, judge, refine, around and around until the answer is actually in hand. One shot solved. Judgment solved. The retriever finally knows when it has failed. And that single ability is worth more than any embedding upgrade you will ever ship. Now, the proof this is not just theory. It is sitting on my machine. Claude Code is the coding agent I use every single day. Here is the part most people never notice. It has no vector database. It builds no embedding index. Zero. So how does it find anything in a codebase with thousands of files? Watch it work. I ask where a feature lives. It runs grep, a plain text search from 1973. The first search is broad. Too many hits. So it narrows the pattern and searches again. Then it opens 2 files, reads them, realizes the real logic lives somewhere else, follows the import, searches a 3rd time, and lands the answer with file and line number. That is the loop from the last scene, running for real. Search, read, judge, refine. And it beats a vector index at this job for 3 reasons. Code needs exact matches, not vibes. Function names, not paraphrases. Your files change every minute, and grep is never stale. And when a search whiffs, the agent course corrects on the very next turn. There is even a research paper about this pattern, asking, is grep all you need? Because the harness around the model, the tools, and the loop turned a dumb text search into a smarter retriever than a semantic index. Sit with that. The intelligence moved out of the index and into the loop. Let's generalize what Claude Code just did, because the pattern transfers to any data you have. An agentic retriever makes 4 moves. Move 1. Plan. Break the question down. Decide what evidence would settle it. Move 2. Pick tools. Keyword search for exact names. Semantic search for fuzzy meaning. A database query for numbers. Grep for code. The agent chooses per question, not per pipeline. Move 3. Judge. Read the results and score them honestly. Thin evidence. Try again. Contradictions. Dig deeper. Move 4. Stop. Enough evidence, answer, and cite where it came from. Now the honest trade-off. Every extra hop costs tokens and costs seconds. Agentic RAG is the expensive tier. You do not use it to answer what is the refund policy. You use it when the question is worth thinking about. Cheap reflex for cheap questions. Expensive judgment for expensive ones. That is the rule. That solves thinking. Now, let's solve relationships. Failure 2 needs a different data structure, not a better loop. Enter the knowledge graph. Instead of a bag of chunks, your knowledge becomes a network. Entities as nodes, people, projects, tools, incidents, and typed edges between them. This depends on that. She reviewed this. That caused this. GraphRag retrieves by walking that network. And here is how it actually works with what you already have. Because this is the part people get wrong. The graph does not replace vector search. They work together. Vector search finds the door. The graph walks the rooms behind it. Your query lands on the right entity by similarity. That is the door. Then the retriever follows edges, hop by hop, collecting connected facts a similarity search would never surface. Those are the rooms. Remember the librarian. Naive RAG hands you the shelf that looks right. The graph is the card catalog, cross-referencing everything, so the librarian can walk you to the exact answer. So let's replay the question that broke vector RAG. Who reviewed the pull request? That introduced the bug. That caused the outage. On a graph. This is not a search problem. It is a walk. Start at the outage node. Follow the caused by edge to the bug. Follow the introduced by edge to the pull request. Follow the reviewed by edge to a name. 3 hops. Done. With a paper trail, you can audit edge by edge. And the numbers back this up. A benchmark on real enterprise questions found large language models answered about 17% correctly over the raw database. Over a knowledge graph of the same data, 54%. Studies report up to a 3x accuracy lift on relationship-heavy questions. 3x. Not from a bigger model. From a better shape for your knowledge. Microsoft even built GraphRag into an open-source pipeline that summarizes whole communities of your graph. This idea has gone fully mainstream. Enough slides. Let me show you my actual second brain. I keep a knowledge base of every project I run. More than 24 projects, all curated markdown. And I wanted to know if a graph layer was worth it. So I ran an experiment with a tool called mnemon. A single binary, open source, stores everything locally in SQLite. No cloud, no API keys. Mnemon speaks 3 verbs. Remember, link, recall. An agent stores an insight, links it to entities, and recalls it later. Under the hood, it maintains 4 kinds of edges: time, entities, causes, and meaning. I pointed it at my knowledge base. 23 project docs went in. It derived 66 explicit links from my own metadata. Then, it auto-extracted 365 more entity connections. 431 edges total from a folder of markdown. And this is the interactive graph it produced. This is on screen right now. My whole professional life as a network. Watch what happens when I pull on one node. My social media pipeline connects to the CLI tool that drives it, which connects to 3 other projects I had half forgotten. Now ask the hook question. Which projects depend on this one tool? On the graph, that is just follow the edges backward. Every dependent lights up. No embedding could have told me that. One honest caveat. Auto-extraction gets noisy. It once decided the word next was an important entity. Graphs need gardening. But the relationships it does catch, nothing else catches. Mnemon fits my corpus because my corpus is prose. If yours is code, look at graphify. Graphify is a folder to knowledge graph compiler, and it is huge. 79,000 stars on GitHub. For code, it uses tree-sitter parsing. Deterministic, fully local, about 40 languages, 0 API calls. For docs and PDFs, it uses an LLM to infer relationships. And it labels every edge as extracted or inferred, so you know which links are facts and which are guesses. One command, and you get an interactive graph of your whole repo, plus a written report of the strange connections it found. Full transparency. I evaluated it for my own knowledge base and passed. My corpus is 99% prose, so the code parser had nothing to chew on. Right tool, wrong corpus. That is the real skill here. Match the tool to the shape of your knowledge. Code heavy, graphify. Prose and agent memory, mnemon. Enterprise scale, Microsoft's graph RAG on Neo4j. So we have thinking and we have relationships. Last promise. All of this power in one command. The tool is called QMD. Open source, written by the CEO of Shopify for his own notes. It runs entirely on your machine. Here is everything part 1 taught, in one binary. It chunks your markdown, embeds it with a local model, indexes it for keyword search too. And when you query, it runs both searches, then re-ranks the results with a small local model. Hybrid retrieval with re-ranking for free. Watch the real thing. I ask my knowledge base, which tool drives LinkedIn and X from my logged in Chrome. This is my actual terminal, my actual notes. 30 milliseconds. The right document, first hit. I measured 92% precision on my own query set on a Mac Mini, costing $0 per query. And the killer feature for this channel. QMD is also an MCP server, which means my agents can use it as a tool. Claude Code calls my knowledge base the same way it calls grep. Notes in Markdown. One command to index. Every agent I run can now recall everything I know. That is the second brain wired up. That is the whole promise of part 1, paid off. Now zoom out, because you have seen all the pieces. Let me show you how they snap together. The modern retrieval stack has 3 layers. At the bottom, your knowledge. Markdown, code, tickets, wikis, written down and kept honest. In the middle, 3 kinds of index. Lexical for exact names, that is grep, and keyword search. Semantic for meaning, that is embeddings. Relational for connections, that is the graph. And on top, the agent. The loop that plans, picks an index per question, judges the results, and keeps going until it is sure. Notice what happened to RAG in this picture. Retrieval stopped being one algorithm. It became a toolbox with a brain choosing tools. This is exactly how my own setup runs. My notes at the bottom. QMD for keywords and meaning. The mnemon graph for relationships. And Claude Code on top, deciding per question how to look. Vectors find what looks alike. Graphs find what belongs together. Agents decide what to trust. So what should you actually build? Here is the honest ladder. Screenshot this one. Rung 1. Plain RAG. Chunks, embeddings, top K. Perfect for FAQ bots and single document questions. Cheap, fast, fine. Rung 2. Hybrid plus re-ranking. Keyword and vector together, then re-rank. This is the production baseline. Tools like QMD give it to you in one command. Rung 3. Add a graph when your questions are about relationships. Who owns? What depends? What caused? If your users ask chain questions, similarity alone will keep failing them. Rung 4. Go agentic when the answer is worth real money or real minutes. Research, debugging, due diligence. Pay the tokens, buy the judgment. Each rung costs more latency and more compute than the one below. Climb only as high as your questions demand. But know the ladder exists because your competitor's retrieval is climbing it right now. So, is RAG dead? You have heard that take 100 times by now. Here is what actually happened. RAG grew a brain and a memory. The brain is the agent loop. Retrieval that thinks, judges, and retries. The memory is the graph. Knowledge that holds its connections, not just its words. And the tools for all of this are free, open source, and running on a desk in Singapore right now. Retrieval stopped being a pipeline. You copy from a tutorial. It became an engineering discipline. The people who learn it are building agents that actually know things. Don't guess. Retrieve. And now you know how to retrieve like it is 2026, not 2023. The Agentic Engineer. New episode every other week. If this leveled up your RAG, part 1 makes the foundations click. It is right here. See you in the next one.